Thank everybody for joining us. I know it's towards the end of the day, but the talk today is more devs, more problems. Actually, because this talk was written before we actually announced the product, couldn't actually announce it, but I was actually going to say something about Tanzu Mission Control, but the best byline we come up with, enabling self-service access to Kubernetes. My name is Fabio Yeon. I'm the senior staff engineer at VMware. A little bit of an intro. I started my journey with Kubernetes before it actually even shipped. I was part of the team at Google. I actually was a tech lead and helped build out and launch a product called the Google Container Engine, now GKE. And after a couple of years of working at Google, I decided to join a little startup called Heptio, started by the co-starters of Kubernetes, Joe Beta and Craig McCluskey. And then, well, last year we joined the VMware family, and here we are. So the challenge we're trying to solve is this. Kubernetes is, shall we say, becoming an industry standard, and brings a lot to the table in terms of like rapid innovation, multi-cloud, and of course, improving your resource utilization of your infrastructure. Of course, for a lot of people though, and a lot of organizations, the journey to Kubernetes kind of starts like this, where you provision a cluster to either existing infrastructure or public clouds, and your developer starts using them because they find the productivity gains from them to be higher. Over time, of course, you may come to your IT department saying, I want Kubernetes on my clusters, on my servers and whatnot, and sometimes they're bespoke configured clusters. But all of a sudden, you start getting this little bit of clusters popping up that you didn't quite know where they were. So you start having a picture that looks a little bit more like this. I'm sure there are clusters out there in the wild. I'm sure developers are accessing them through some mechanism. Who knows if they actually are applying their access policies correctly. I don't know who has access to what. More importantly, nobody in the C-suite, the CSO or the CIO, at some point, sometimes even the IT folks are like, I'm not quite sure what's going on there. All I know is that things are popping up and my developers are running and accessing stuff. This becomes a reality. The reality is that as the number of Kubernetes clusters starts increasing, the complexity of the whole thing starts going up. There's fragmentation across teams, there's visibility security challenges, and you may get a bill at the end of how much things are costing you, but you're not quite sure where they're kind of going. More so now that we're in a world where all the major cloud providers provide Kubernetes. And of course, you start running the challenge of each one of those things have a separate security domain. The way they manage the role access, the RBAC rules, they're different, they're separate. Each one of them integrates into their own respective IAMs. And of course, individual clusters have needs, like upgrades, they need monitoring, they need backups. Security policies are applied individually. And then, try to manage and cross-cluster traffic starts becoming challenging. And in the end, one of the things that you start finding out is that as you start provisioning more and more clusters, some of those benefits that somehow you try to attain from Kubernetes, the increased resource utilization of sharing of resources and decreasing your costs, and increasing the utilization of the overall infrastructure starts going down. And this, of course, drives up the cost. So the solution that we come up with, and this is a journey that started during the Heptio days, which is continuing on at the VMware, is Tanzu Mission Control. Something that helps you manage and bring kind of a little bit of clarity and shall we say, oversight into this whole set of challenges across many clouds, clusters, and of course, teams. Some of them, providing, shall we say, a consistent way to enable and to see who has, access to individual clusters and be able to set them, to be able to define policies and push them consistently across your fleet. Depending on the providers, we can also help you manage the life cycle of them, meaning provision, scale up, scale down, update, delete. You have unified views across all of them, automated policies, and of course, help you monitor the costs. Of course, this does not, it's not like a trivial one-time kind of a thing to get going and to just do this. It takes a little bit of work to actually set up your systems in a way that can leverage all this. One of the things that we kind of decided to do architecturally when we started building this product is that we wanted to apply as many of the Kubernetes principles as we can in building this product for customers. So, one of the things that we tried to do is start with a declarative application-centric policy model. Now, this one took a little while for us to iterate through, but the principle of it can be summarized like this. There exists a resource hierarchy because we live in a physical world and we want to be able to have an ability to say that a cluster belongs to some grouping and therefore and each belongs to an org. And therefore, I'm able to manage them as physical resources as a group of clusters. A secondary concept that kind of exists as well is that Kubernetes allows you to share a cluster via namespaces. For those that may not be familiar with it, namespaces are basically a way to provide, shall we say, very much like in Windows or Macs, where you can have different users using the same computer. Namespaces allow you to have the same, like a slice of the cluster to run your own workloads with your own segregated set of like objects and role bindings and whatnot. Now, typical models map namespaces all to a single cluster. So you can either share a cluster, but it's hard for you to, for example, manage namespaces across clusters. This is where we are introducing the concept of a workspace. I know the naming is hard, and this is like the tech world where like a word like namespace or global namespace or service has like 3 or 4 different meanings behind it. A workspace is nothing more than a grouping of namespaces. If that's the takeaway from this, I mean, I'll be very, very happy because trust us, it took a while for us to iterate on this. But a workspace is just a grouping of namespaces. What does this mean? If a namespace is being managed inside a workspace, it means that any policies defined within the workspace get applied automatically across all of them. You want to set a pod security policy, you want to set an image policy, you want to give somebody an access to a particular workspace, we will go ahead and compute the Kubernetes objects that has to be set on those individual clusters, on those namespaces, to ensure that like, hey, all of them are replicated and generated correctly. So in the high level, it simply means is that as your cluster is associated with Tanzu Mission Control, we are able to then help you manage the individual Kubernetes namespaces and objects within it. And this is the other thing about it, we don't care whether we provision the cluster for you or whether it's an existing cluster that you provision either yourself or through another cloud provider. We will install an agent on each one of those clusters as part of the initial setup phase. And from that point on, you should be able to control and manage through all of them through Mission Control. So, how do we do all of this work? You group namespaces across clusters. You define a namespace policy. And we will compute then the namespaces, the configuration needed to be pushed out to each individual cluster. There is another highlight that I want to bring out. The set of policy, because of the dual hierarchy between resource and workspaces, the set of things that you can set at the cluster hierarchy level, the policies over there are slightly different than the ones that can be set at the workspace level. There's a natural division that occurs, which is Kubernetes has a certain set of policies that are applied cluster-wide, and there are policies that can be set on a per namespace basis. And this provided to us a very easy opportunity to say, like, you can set policies at the workspace, at the cluster level that are applied at that level of the resource. But anything that can be defined at the workspace must be settable on a per namespace basis. So, kind of keep that in mind. Sorry, this is a kind of a marketing slide that I stole. But this is a little bit forward-looking in terms of the policies that the type of policies that we can actually control in Tanzu Mission Control. And first of them, of course, is the access policy, basically defining cluster and role bindings for your clusters. quotas, which basically means collecting the resource utilization of all the pods and services running in your clusters and being able to aggregate them in some form. Security, providing ability to set things like pod security policy, network policy, and image policy. And of course, configuration, which through the open source Sonobuoy project, we were able to run some conformance scans and make sure that your clusters are configured in such a way that they're conformant. And at some point in the future, also add capabilities like CSI scans to make sure they're also secure. Given that it's a little bit of a more developers focused, I want to dive in a little bit and mention how we actually do access management across the various clusters. So one thing to keep in mind is that Kubernetes doesn't really have a concept of a user. But what it does have is a very flexible authentication model that is pluggable. Now, every single cloud provider, and I'm sure if you have Kubernetes clusters provisioned in your current infrastructure, you had to set up an authenticator to your IDP or identity provider to authenticate users, as they call, into your Kubernetes clusters. The way to associate this, share that information across multiple IDPs is via federation. A specific challenge that comes up when you start having clusters, shall we say, in your infrastructure and some of them in a public cloud, AWS, Azure, Google, is that there's a set of logins you have to use to log into your current infrastructure here, but you have a different set of logins to log in over there. Unless somehow behind the scenes you're able to federate your IDP across them and get a more unified view. I have to disappoint you all here, but Tanzu Mission Control does not solve this problem per se, because we're not an identity broker. But what we do help you solve is that no matter which IDP your cluster is using, we let you at least observe what the role bindings are, so at least you have an introspection as to who is having access through all of my fleet. And the second thing that we allow you to do is that if you give us the identity that you want to have access to this, we will be more than happy to create the cluster role bindings, and clusters the role bindings in the namespaces. Again, wonderful naming by the developer team in Kubernetes. Sorry, quick question. Oh, sorry. So, but at the end, the result is we are able to provide you auditability and visibility into the access policies across all of them. So you're still logging into the Kubernetes clusters to your standard kube control mechanisms. It's just that Mission Control gives you both the introspection and the ability for you to set the role bindings as you see fit. And, good. Given the fact that, this is a more developer-focused thing, I decided to just jump in more into the demo in a few slides. So this is Tanzu Mission Control. So this product is currently on early access preview to some select customers, and we're still iterating through it quickly and try to get this thing out to market as fast as we can. But I'm happy to say that we have one of the most requested features out there in the market already implemented, which is dark mode. Thank you. So I always like to start with this view because I think it starts, illustrating a little bit the concepts that we want to highlight with Tanzu Mission Control. The first and foremost, which is this is a fleet management tool. This is not about managing or accessing a single cluster and seeing and introspecting whatnot. There are many dashboards that help you do that, including one from VMware open source called Octant, which my colleague Brian Lyles has written. Go and check it out. But this is all about the concept of managing a fleet of clusters. So like I mentioned before, one of the ways to start with this, you can either provision a cluster, and we enable you to create currently a compliant cluster on AWS on your account, or you can attach a cluster, which, this is the flow where you can start configuring and getting the configuration needed to install the agent on your existing cluster so they connect back to Tanzu Mission Control. So if you look at this particular view, you can see there's a variety of both provision and attached clusters. Because we can provision AWS clusters, they show up like this, or there's a variety of clusters from either Enterprise PKS, Google, or AWS. If I step into one of these clusters, for example, I can get a view of what's going on in terms of the high-level configuration of the infrastructure, see the existing nodes that exist. Actually, this is not the cluster I want to show because this is the small demo one. This is the one I want to show because it has far more nodes, and I can get a visibility into, for example, what are the pods running in that specific node versus a fleet-wide, whether it has any node conditions that may trigger, shall we say, a warning or an error from me, and of course, some high-level configuration information on a per-node basis. I can inspect the namespaces on that particular cluster, and of course, also get an insight onto an individual workload of that cluster. And for some of these, also take a look at what are the pods, what are they running, and of course, the raw YAML for them. On a per cluster basis, this thing looks just like any other dashboard that exists. So where's the power on this? The power comes from the fact that I can go here and start observing this on a fleet-wide view. So if I'm judicious about, for example, how I label my things, I can get, for example, an idea of where all my Acme Fit workloads are running across my clusters, across my fleet. And of course, understand a little bit more what their health status are and understand what's going on individually.
Increase the font size, please.
So sorry, I got a request to increase the size of the screen. Is that better?
That's
better. Okay, sorry about that, apologies. So again, the theme here is fleet management. We are able to provide you both introspection into the fleet of what's going on across your whole fleet, so that you're not managing this on a per individual cluster basis. So where does the extra value, this is interesting from an introspection perspective. I can get a visualization of the data and workloads. Where does the other stuff, the policies kind of come into play? So I mentioned that there is the grouping for clusters. So under a cluster group, which we can define here, you can associate a set of clusters to a cluster group. Now, very much like workspaces, cluster group is just a name. As the name implies, it's just a grouping of clusters. Why do you want to do this? Is so that when I go to policies and I'm looking at the cluster group via development, I can see the clusters that are associated with it, and within that, I can then start setting the various set of policies that I want for all those clusters belonging to that cluster group. I'm still able to go on a per individual cluster and set direct policies, for example, for access or image registry and so forth. But typically, what most folks want to do is be able to manage this across your fleet of clusters. So I can go to this one and say, hey, from a development cluster, these are the settings that I have given. And I can go ahead and either add a user group or service account that says, hey, for this group, let me give them cluster edit access so they can access all of them. And this is my Tanzu demo team, and I can just add it. And from this point on, anybody who belongs to the Tanzu demo team, and I just realized that I typed in not an email address, can access the clusters that belong to that cluster group, which is fine if you want to provide the level of granularity access at the cluster level, meaning you want to give a team or teams a set of cluster or clusters and say, here, these are all your clusters for you to use. You can do whatever you want. And there are use cases for that particular set of policies. Depending on how you want to manage your infrastructure, the power of the workspace may be a better construct. So for this one, let me go ahead and create a new workspace. I'm going to call this, thank you, Chrome, giving away my joke. And say this is the bike shed workspace. And I'm going to add a label to it so I can keep track of this and create the workspace. And right now, no namespaces are being managed under the bike shed workspace, which is fine. I get to show off the MCTL, a little bigger, command line, because this is an API-driven, declarative API first kind of technologies, of course. We're going to have a command line. And I'm not going to sit here and type in a bunch of things. So I'm going to go ahead and create a few more namespaces. So let's take create the red shed. And then I'm going to ahead and create like a few more of these across multiple clusters, create a bunch of namespaces. Done. Perfect. So let's hope that yes, it worked. So under the bike shed workspace, now I have a bunch of sheds, bike gray sheds, green sheds, that are namespaces that I've created across a variety of different clusters. Enterprise PKS and SP1 demo, and of course the VM world. And of course, each one of those has a different label. Great. And of course, none of them have any workloads, which is fine. Because I want to go to my policies now, and on the workspaces, be like, hey, I created the bike shed workspace. And then here, I want to go ahead and say like, hey, I'm not going to give you full access to a sole cluster to your team. For the bike shed team, which I know they're geolocated and therefore I have multiple clusters for them, or maybe they are development, production clusters, variety of use cases, it's up to how you define it. I'm going to go ahead and say like, you know what? The bike shed team at gmail, mail.com. Doesn't matter. Whatever the alias is for that particular team, I'm going to go ahead and add it to here and save it. So from this point on, every one of these namespaces should be available to the bike shed team to use for their, for their development, for their deployments, for whatever they need to do. And of course, image policies and network policies, of course, apply equally to the workspace level, so you can actually then set them at this level. Or, again, because this is a hierarchy, I can also go to an individual namespace and say like, hey, just go ahead and add role binding just for this particular namespace. For example, maybe this is the one that I need to give access to my PMs so they can use it for demo purposes. I can just add my role binding here, which then if I go back here, the bike shed workspace is here, and then I'm, where am I? Here we go. Nope, nothing scheduled yet. Okay. So, and this is about it. One final thing I wanted to mention is that the set of policies that we're going to be adding over time is going to keep on growing. We're starting with some of the 4 basic ones that are some of them built in from Kubernetes. Image registry is a new one that we're building using the extensibility points existing already in the API server for Kubernetes through a dynamic admission controller. And of course, one of the things that we can also do is we have an integration with Sonabuoy. I talked about the fact that we had the ability to take a look and see if your cluster is being conformant. So in the situation, like after a cluster has been run, oops, wrong place. I can take a look at the result set from a conformance test on a particular cluster and see whether it's been, it passes all the conformance tests from Kubernetes and so forth. And this one actually did. So we're doing on time. Great. Let me go back to presenting and say yes. Okay. So love the slide for marketing. That's why I'm kind of using it again. So one of the goals that we had from Tanzu Mission Control was, again, to bring that order. So one of them is that the IT folks are able to then have provenance and understand what's going on a fleet of these Kubernetes clusters. My developers are able to have a way to do self-service access and be able to have the ability to access the infrastructure without being a ticket-driven model. And most importantly, through the various extensibilities that we can add, the CIO and the CSO are able to get visibility into what's going on across my teams in terms of budget utilization and so forth. And in the end, basically, depending on your personas, you're able to answer a number of questions across your Kubernetes deployments, wherever they may be. And the call of action that I have, this is the URL for the Tanzu Mission Control if you want to get more information from VMware. And this is also my email. I would love to, if you have any questions and whatnot, feel free to email me, and then I'm also on Slack on the Kubernetes channels if you're in that. Otherwise, I'll be available to answer any questions afterwards. Okay, thank you. Yes.
Is this a free product or a licensed one?
The question is this a free product or licensed product? This is, unfortunately, depending on your point of view, a licensed product through VMware, yes.
You spoke about budget. Does it pull the pricing and the budget information from all the cloud providers and centralize and give you that data?
So the question was, how do we provide the visibility into the budget and utilization and the cost of the infrastructure? This is a feature that we're implementing in tandem with a product called Cloud Health, which is another acquisition that VMware did, but it's an integration through them. And they actually are able to resolve the cost of your VMs and whatnot through tags on your infrastructure that we can set through TMC, Tanzu Mission Control. So that's how the reporting and the cost management can be done. Yes?
Is there some sort of declarative config file that you can check into Git that would have all of your mission control information?
The question is there some way to do a file they can actually use to check in and to do Git operations? And actually, I just realized that I did not do this. This is the YAML file for creating a namespace in Tanzu Mission Control. Like I said, we are borrowing a lot from the Kubernetes community. We are Kubernetes people. And so we are using a declarative syntax very much like Kubernetes has done in our API. Now, a couple caveats. It's Kubernetes-like, but it's definitely not the Kubernetes file object format. I personally, as an engineer, have some questions, concerns. This is actually a YAML generated, backed up by a protobuf using gRPC to our API servers. The format will feel familiar to anybody who's using Kubernetes, but it is certainly not Kubernetes behind the scenes. Sorry, one follow-up question?
So if you do it on the UI, will it spit that out for you? Or do you have to write it?
So the question is, in the UI, will we spit this out, or would you have to figure out this manually? Right now, we do not spit this out in the UI, but actually that's a very interesting feature request, something to consider. Yeah, sorry.
Like for ECF, we have CF management. Similarly, do you have any CLI so that we can manage command line automation purpose?
Oh, the question is, do we have a CLI? Yeah, the MCTL command line that I was showing off, MCTL, actually is the command line interface to Tanzu Mission Control that we built. And therefore, this is the one that you can actually use then to access our product. I'm so sorry, I think I skipped you before.
PKS?
I'm sorry?
PKS?
I'm sorry, what about PKS?
PKS?
Can you connect to PKS?
Oh, sorry. Yes. We can connect to existing PKS clusters. Unfortunately, we do not have integration with the PKS control plane, so we cannot provision a cluster through to PKS. But if you have existing cluster, PKS, EKS, whatever they may be, we can install the agent and you can connect to it, yes.
How do you do networking?
So the question is, how do we do network between them? This is a SaaS product running in the cloud, so we do have to have connectivity between your cluster and us in the cloud. My PMs may not like this, but we are exploring other alternative ways to run and provide this, but I have nothing else to add at this point on that one. Sorry. Sorry, one more, yes.
As a SaaS, do the agents connect out, or do you require connection?
So the question is, as I said, so we connect out or connect in? No, we definitely connect out because we find that at least going out helps you bypass a firewall and other issues. We are also adding support for proxies, so we're able to then connect through existing proxy if you have something like that. I'm so sorry, folks. They're telling me that I have to cut out because we are at time. But if anybody wants, we'll be happy to ask any questions, and of course my email address. And then thank you very much.